Friends, myself Shankar Manose, and today we have to see examples of parametric curves. In previous lecture, we have discussed the theoretical part, that is how to trace the parametric curve. Now, in today's video, we will discuss how to trace the parametric curve examples. Okay, let's start with the first example. Suppose at the time of theory, I have told you the only three examples are there: cycloid, tractrix, and asteroid. Out of that, first we will consider a first cycloid, that is, trace the curve x is equal to a into sin t plus t, y is equal to a into 1 plus cos t. Okay, to trace this curve, we have to consider the four properties of that curve: symmetry, origin, limits of xy, and tangent. For that, just consider draw a table like this way. We can consider the first one, symmetry. What is the condition for symmetry? That is, we have to replace t by minus t if x remains unchanged, symmetric about x-axis. If y remains unchanged, symmetric about y-axis. Clearly, by observation, cos t is an even function. When we replace t by minus t, cos t remains unchanged. Therefore, curve is symmetric about y-axis. Similarly, now go for the next, origin, limits, and tangent. We will get these observations by our table. And how to draw the table? At the time of video also we have discussed, if a function x contains sine theta minus theta, then we have to use the table as 0 to 2 pi, otherwise minus pi to pi. As this curve is of the form sine theta plus theta, therefore our table will be that is, these are the values of xy, and so table 0 to 2 pi. Okay, put these all values, and we know that dy by dx is nothing but dy by dt upon dx upon dt. Differentiate x with respect to t, differentiate y with respect to t, and take the ratio, and the value is minus tan t by 2. Okay, now just put the value. If you put t is equal to 0 in an equation of x is equal to a into sin t plus t, we get the value of y, we get the x as 0. If you put pi by 2, we get a into. In this way, we can complete our table. Similarly, for y, if you put 0, we get cos 0 is equal to 1, 1 plus 1, 2, 2 into a, 2a. Similar way, in this way, we can find the remaining values, and therefore we get the points as 0 to a and the remaining points. Okay, now by observation we have to write whether the curve passes through origin or not. Clearly the points shows that there is a no point 0 0 in the table. At t is equal to 0, the values are 0 and 2a. Therefore the curve does not passes through origin. Okay, now let's find the dy by dx also. At t is equal to 0, tan 0 0, therefore 0, minus 1, infinity, 1, and 0. Now write on your observations. At t is equal to 0, what happened? X is equal to 0, y is equal to 2a. Curve does not passes through origin. Next, limits of x. Generally, where x is varies from 0 to 2a pi. That means it is for 0 to 2 pi. If we consider at the negative side, that is 0 to minus 2 pi, it will be varies as 0 to minus 2a pi. Therefore it varies to plus side up to infinity. For negative side, it tends to minus infinity, because the cycloid is a rolling cycle uniformly without sliding. At the time of definition, we have seen this one. So limit for x, it is minus infinity to plus infinity, and limit for y, always y varies from, that is 0 to 2a, 0 to 2a. Okay, in this way we have completed our information that is theory part for the curve, the first cycloid. Okay, once again I will revise this: symmetry, origin, limit and tangent. This is our first table, and second one is the values of we have to prepare the table as 0 to 2 pi, because x is the form sine theta plus theta, sine t plus t. Otherwise, if it is sine t minus t, our table will be minus pi to plus pi. Okay, uh, this way we have completed our table. Now let's try to draw the curve. This is my x-axis, this is my y-axis. Our range for x is, it is varies from minus infinity to plus infinity. Just trace the finite points, that is 0 to 2a, that red points we have considered xy, red points 0 to a pi 0 and 2a pi 2a. Okay, this is 0 0, this is 0 to 2a, our highest point on y-axis. Second point is a pi 0. On x-axis the values are a pi, 2a pi, 3a pi, 4a pi. On negative side, minus 2a pi, minus a pi, minus 2a pi and minus 3a pi, in this way. Therefore a pi 0, it is point on positive side of x-axis. Next one is 2a y coordinate, and 2a pi is my x coordinate. Therefore the point will be in this way, and just joint these curve. As we have seen, there are two tangents which are parallel to x-axis. dy by dx is equal to 0 at 0 to a, and dy by dx is equal to 0 at the last point, the upper side points. At these 2 points, tangent is parallel to x-axis. Therefore we have drawn a tangent. Next, infinity, that is a pi 0. In this point, tangent is parallel to y-axis in this way. And these are the two tangents. Now our shape of the curve will be, as it is tangent, at the position of tangent our curve will be at u shape. Therefore in this way we have to joint the curve. Okay, this is my curve. Okay, as this is a rolling circle, therefore we can joint the point, complete the curve, half part of the curve, that is minus a pi. Curve is symmetric about y-axis, therefore. Okay, and the next, this is the continuously running curve. Okay, hope you understood. Let me explain again. We have considered our first cycloid: x a into sin t plus t, y a into 1 plus cos t. Symmetry, simple. For every cycloid, general form of cycloid, y always contains cos, therefore it is symmetric about y-axis. And origin, limits and tangent we will get from the table, and table is fixed, that is 0 to 2 pi for every cycloid. Put the values, all the values, xy and dy by dx, and find the values. Put t is equal to 0 in x, get the value of x, pi by 2, pi, 3 pi by 2 and 2 pi. After completing the values of x and y, construct the points xy as 0 to 2a, a pi 0, 2a pi and 2a. And we know that the tangent, how to find dy by dx, that is dy by dt upon dx upon dt. After simplification we get the value as minus tan t by 2. Put the values of t in dy by dx so that we will get the values of dy by dx. And only we have to consider dy by dx as 0, infinity and 0, because if dy by dx 0, tangent is parallel to x-axis. If dy by dx infinity, tangent is parallel to y-axis from that point. Okay, in this way we have constructed our all information, and on considering on graph paper we have traced the curve as considering x-axis, y-axis. Only we have to trace the finite points, that is a red color points, 0 to a pi 0 and 2a pi 2a. constructing these points. Next is draw the tangents, that is 0, infinity and 0. After drawing the tangents, just we have to connect the curve, and that will be our first type cycloid. Okay, thank you.